let's talk about optimal pricing, how to set a price to get the most money you can. It turns out economists and mathematicians think about this, think about the graph going on here in different ways. So let's highlight that in case you've already taken an econ class and you know how to do it from an econ point of view. So in econ world, you put the demand on the x-axis and the price on the y-axis. But in the math world, we tend to say, well, a store can set the price they want to charge and just see how many people buy items or how many items get sold. So they'd put the price per item on the x-axis because that's kind of the independent variable. You can directly set that. And then the demand, the number of items sold, so demand is number of items sold, will go on the y-axis. So that's the way we'll think of it. And if you want to do it in econ, you can do it that way later. So what does the demand curve look like? Again, in the math point of view. So we'll say demand number of items sold and price per item. Well, generally you would expect the higher the price you set, the lower the demand will be. If I charge $1 million per pound of apples, I'm not going to get very many customers. So we expect it to be decreasing. Maybe it's not linear everywhere, but maybe if I zoom in enough on the region I care about, then it's linear. That's kind of the idea of calculus, right? And let's say that demand at price P is some slope times P plus some intercept with the slope less than 0 because we have a negative slope there. And we want to set a price per item to maximize what? Not demand necessarily. I can create lots of demand by giving away products for free, right? If I set the price to 0, I'll have lots of demand but not make very much money, mysteriously. I don't want to maximize the price per item because then I'd be charging $1 million per pound of apples and no one would buy it and I would still make no money. So what I want to do is set a price to maximize profit, at least in the short run. I should also think about like long-term customer satisfaction and stuff like that, but let's just go with short-term thinking for now. So set a price to maximize profit. And generally we'd say profit is revenue. Revenue is how much money you're taking in minus cost, how much money you're spending to make that revenue. Just to make life simple, let's ignore cost for now. Maybe you already spent the money to buy this batch of apples or whatever, and now you just have to set your price to maximize total revenue. We'll come back later to the condition where there's costs. So what is the revenue if I set a price of $1.50 per pound of apples and I sell 1,000 pounds of apples? How much total dollars am I bringing in? Well, that would be the price per item times the number of items. That's the accounting principle we talked about in the other video. So then let's write a math formula. The revenue at a certain price would be the price per item times the number of items you sell. Do we have a name for that? Take a sec to think. That is the demand at that price. And for now we're using a linear demand function, so we can say m times p plus b. And we could do a little bit of algebra, mp squared plus bp. So p is acting as our x value here. What does that look like? Let's graph it real quick. Well, it's got a squared term, so it's a parabola. And if P equals 0, then I get 0 here. I'd have great demand, but I would make 0 money on each item. So it would touch here. If I set the price really high, we said I would sell 0 items, so I would make 0 total dollars. And we said this is a parabola. Is it going to be a smiley parabola like that going through those 2 points? Well, remember m, the slope, is negative, so I've got a negative attached to the p squared here. So I'm actually going to get a parabola kind of like that. And I want to choose that point because that optimizes my total revenue. That gives me the maximum revenue. So go ahead and do calculus here to find what value of price maximizes total revenue. Okay, welcome back. So we're going to take the derivative. So r prime of p equals m times 2p plus b, just taking the derivative directly from there. Then set the derivative equal to 0. So m times 2p plus b equals 0. Solve for p. So I'm going to subtract b from both sides and then divide both sides by 2m. And I'm going to get p equals minus b divided by 2m. Does it seem strange that price would be negative? Well, remember m is less than 0, so overall we would get a positive number here. All right, and what is there to do? Maybe plug it all into Desmos and see that it worked. So when we're checking, one thing we want to do in Desmos is set up, let's say d of p equals m times p plus b, and make sliders out of m and p. Sliders for m and p. And then I'd say r of p equals p times d of p. And then that would show me the r of p curve, which we already graphed there. But one thing I would do to check my algebra here is I would type in this formula where I had done a little bit of algebra, and that should still be equal to p times d of p. So I would also type mp squared plus bp, and these two curves should be the same, and if they aren't, then I did some algebra incorrectly going from this to that before I took derivatives. So I would type both of those, then turn one off and on and make sure that the two of those overlap. One last thing, estimating the demand function here in any real situation is really complicated. It depends on lots of things. It depends on what price your competitors are charging. It depends on how much money you spend promoting the item. Even if you're charging the same price, if more people know about it, you'll probably get more demand. So there's all kinds of randomness there. Some websites have been known to randomly charge different people different prices and gather data on how many items they sell when they set the price to this or that. I'm not sure if that's legal. Other websites have been, or maybe the same website, has been known to look at your buying history and see, do you tend to buy expensive stuff or cheap stuff? And if you tend to buy expensive stuff, maybe they'll quote you a higher price on this item than they would quote to someone who tends to buy cheaper stuff. Is that legal? I don't know, but it's a good data ethics kind of question.